Welcome back. And if you have been liking these videos, please hit like and subscribe. The learning objectives for this video are building and running our first C# script by giving our car movement. Let's get started. Last we left off, we successfully imported assets from our scene from the Unity store. We have come to the point in our learning where we will begin to cover using C#. This is the part that can be intimidating to many, because we now move from navigating settings to actually scripting with computer language. Bear with us, we will breaking it down into digestible pieces. Right-click in the project window. Go to Create and Folder. Name it Scripts. Create a new script in that folder, and name it Player Movement. Now select our car, and drag our script in the bottom of the inspector window. Click the name of the script in the inspector and Visual Studio will open. Now we can begin to edit our code. At the top we have our using statements. These statements import a namespace, which is a collection of classes and data types, which your script will be able to access. We will not be using the first two using statements that were created by default. Go ahead and delete them. Next we come to the section for the class. A class is like a blueprint for your object. In Unity, all of your scripts will start with a class declaration. Unity will automatically put this inside the script when we create a new one. The class defines the type of data and the functionality this object will have. Next we have MonoBehavior, which is telling us which class our class is derived from. Therefore in this case, the script Player Movement is derived or inheriting from MonoBehavior. After that we have the start function. In C#, a function is a way of packaging code that does something and then returns the value. Unlike in C, C++ and some other languages, functions do not exist by themselves. They are part of an object-oriented approach to programming. A function allows you to encapsulate a piece of code, and then call that code, from other parts of your application. Instead of writing the same code over and over again, you can create a function, and access it anytime you need. This is the structure of a function. The visibility of a class, a method, a variable or a property tells us how this item can be accessed. The most common types of visibility are private and public, but there are actually several other types of visibility within C#. Return type can be either a double, a string, a list or any object. Then define the name of the function. If the function has parameters, or needs to take some parameters, then we define the parameters within the normal brackets. By default, we have a start and update function placed in our script. A code placed in the start function will run once the game starts. We can give our player some movement by adding force to the rigid body. We can give our player some movement by adding force to the rigid body. To do that we first have to reference the rigid body component. After the open curly bracket that follows MonoBehavior, start a new line and type exactly as shown. For the visibility we are going to make it public. The name of the component we wish to modify is rigid body, and for the internal name we will call it RB. Now if we save and go back to Unity. In the inspector window for the car under the Player Movement script, you will see a field named RB. grab the rigid body component, and drag it into that empty field. Now, whenever we write RB in our script, it will refer to this particular rigid body. Click back into Visual Studio. We are now going to add a force to our rigid body, so that our car can move. For the purpose of our game, we need a constant force pushing our car, therefore we will be using the update function, rather than the start function. The start function will only run at the start of the application while the update will make the force constant. Go ahead and delete the start function. When using physics in our game, it's better to use fixed update rather than just update. Between the curly brackets in the update function type RB the rigid body, add force, bracket. 0 for the X, 0 for the Y, and 2000 for the Z. In order to smooth out the movement we need to use something called time delta time. Once your script is identical to this one, hit save and return to Unity. In order for our car to make contact with the surface, we need to add a box collider. The default size of the box collider won't be big enough, so we must adjust it. Use the scene window to adjust. It can be a little tricky getting the measurements just right. Once you feel the box is the right size, hit play and our car should move forward. It's a little bit slow, let's go back to Visual Studio and change the force to 3000. Looks a little better now, but we can tweak it in next video. This seems like a good place to stop the lesson. We introduce scripting in lesson and hopefully you were able to follow along. If you were able to successfully complete this tutorial, congratulations. Until next time, it's your boy Doge signing off from the 6.